Alright, problem 24, gender gap. Candidates for political office realize that different levels of support among men and women may be a crucial factor in determining the outcome of this election. One candidate finds 52% of 473 men polled say will vote for him, but only 45% of the 522 women in the poll express support. So we got to do a 95% confidence interval for the male voters, a 95% confidence interval for the female voters. Part C is do the intervals overlap, and then we got to do a 95% confidence in the difference of the two. And does this interval contain 0? What does that mean? And why do the results in part C and E seem to contradict each other? Okay. All right. So let's do part A. We're going to do panic. So we're going to do P sub M is the proportion of men that I'm going to put support the candidate. Okay. The assumptions and conditions. First one is random. So it does not say that the sample is random, so we're gonna assume that the sample is representative. Okay, the 10% condition. In this case, we're talking about men. So 473 men are less than 10% of all men. Then we got the independent. Each male's response was independent. And then the success failure condition. Let's see. So we got to do 0.52 times 473, and if we do that, that's about 246, and that's greater than 10. And then 0.48 times 473, and that comes out to about 227, and that's also greater than 10. So we met all of the conditions. Name the test. We're going to do a 1 prop confidence interval. Okay. And the statistics, so N is 473, P hat is 0.52, Q hat is 0.48. Okay. And then we got to do the interval itself, so 0.52 plus or minus 1.96 times the square root of 0.52 times 0.48 over 473. Okay, so let's go to our calculator. Stat test 1 prop z int. So the number of successes, x, is going to be 0.52 times 473. And we're going to round that to 246 because it has to be an even number. And 473 is our sample size, 95% confidence interval. We're going to calculate. We get like 0.475 to 0.565. 0.475 to 0.565. So, conclusion, we are 95% confident that between 47.5% and 56.5% of males will vote. Okay. So now we got to do the females. So piece of F is a proportion of females that support this candidate. Okay, so the assumptions and conditions, again, random. We're going to assume the samples is representative. 10%. Let's see, how many women did we have here? We had 522. It's less than 10% of all women. Independent. Each female's response was independent. And then success failure. So success failure, we're going to do for NP, we're going to do 0.45 times 522, and that's about 235, and that's greater than 10. And 0.55 times 522, and that's going to be about 287, and that's greater than 10. Okay. Name the test, one prop confidence interval, and N is 522. P hat is 0.45, and Q hat is 0.55. Okay. The interval, we're going to do confidence interval equals P hat plus or minus Z times the square root of P hat Q hat over N. Okay. So we're going to do stat test, one prop Z int. In this case it's 0.45 times 522. We're going to round that to 235. So this becomes 235. This is 522. And our interval is like, I'm going to say about 0.41 to like 0.49. Okay? So 0.41 to 0.49. So we are 95% confident that the proportion of females that support this candidate is between about 41% and 49%. Okay. So question C says, well, do these two intervals overlap? Okay, well, the male interval is from 0.475 to 0.565. The female interval is 0.41 to 0.49. So it does appear that they overlap. So, well, what does that mean? Well, it appears that there might be no difference in the support between males and females in this candidate. Okay, if you just look at the one prop confidence intervals, but we still had to do a two prop test because, again, the issue is when we do a two prop test, so In this case here, we're not adding the variances, so we got to do a two-prop test. Okay, so parameters, we already defined P sub m and P sub f. Not going to redo that. Okay, their assumptions and conditions, we checked the random condition already, we checked the 10% for both, we checked the independence, but we got to do the independent sample. So random is done. Okay, 10% is done, success failure is done, independent samples. And what are we going to put there? Well, we're going to put that the samples are independent. Okay, one sample did not affect the other sample. Okay, now name the test. We got a two-prop confidence interval. So now we got P hat sub m, and P hat sub m is 0.52, and Q hat sub m is 0.48, and N sub m is 473, and P hats of females is 0.45, and Q hat for the females is 0.55, and the number of females was 522. We don't have to do P pool here because we're not doing a hypothesis test. So we got to do the interval, right? So the confidence interval equals, I'm going to do the males first. So I'm going to do 0.52 minus 0.45 plus or minus 1.96 times the square root of 0.48 times 0.52 over 473. That's for the males. And then the females is 0.45 times 0.55 over 522. Notice how we added the variances here. Okay, so now what we're doing is we're doing a confidence interval for the differences. So let's check this out. Stat test 2 prop z int. Okay, so x of 1, the number of successes, is 0.52 times 473, and that comes out to 246. Okay, out of was it 473? And then for the females, it was 0.45 times 522, or 235. Out of 522, and we're going to do a 95% confidence interval. Okay, and we get, look at this, 0.008 to 0.13. So when we looked at the original intervals here, it looked like they could overlap somewhere in between like 47.5% to 49%, because that would be in both of these intervals, right? But when we do the difference, look what we find out. So what's the conclusion? Okay, we are 95% confident that between 0.008 and 0.13 more males, we can make this 0.8% and this 13%. Okay, that would probably be better. More males support this candidate than females. So is 0 in the interval? No, 0 is not in the interval. So what does that mean? It means that there is evidence that the proportion of men may vote for the candidate is greater than the proportion of women who may vote for the candidate, because there's no negative number in the interval. So it looks like men are definitely more in favor of this candidate. There's definitely conclusive proof that there's more men. Men tend to favor this candidate more than females do. Okay. So what's the deal? You know, what's the deal with this? Is question F. Well, the two proportion method is the proper method. Okay. By attempting to use two separate confidence intervals, you do not add the variances. The whole key here is this: you got to add the variances. Okay. When you're looking at two independent samples, you cannot look at the standard deviation separately. You have to add the variances, and then take the square root of that sum, your standard deviation.